Okay, I forgot to do this last page on 6-9 notes, so here it is. These two things are going to show you why this and this are the answers to the integral for these, so it's the proof kind of it. So we want to take tangent and make it sine x over cosine x dx. And then we use u substitution here, so we're going to say u is going to equal cosine x because your du has to be on top, so you let it be the denominator. So the integral or derivative of cosine is negative sine x dx. You move the dx over. So I got to create a negative and destroy a negative, and then I can rewrite this as the negative integral. And I have 1 over u, and this negative sine dx is du, so I stick du back in there. So this is equal to the negative natural log of the absolute value of u plus some c. Well, we always stick our deal back into u, so we're going to change that to cosine. And if you check this out, this is the same answer that they give right there. Now this next one's way harder, because you actually got to create some extra stuff on here. So what I'm going to do is I'm going to create a new kind of problem here. I'm going to add 1 to it is what I'm actually adding to the problem. But I'm doing this so that I can get a u substitution in for this thing. So what I want to do here is on the top, I'm going to add a secant x plus tangent x on top. And then I'm going to do the same thing on the bottom. So this is actually a value of 1. This is actually 1, so it doesn't change the value. And then I'm going to do the integral of this, which is the same thing. So what I want to do is I'm going to do, again, u substitution. But I want u to be the denominator for the same reason, secant x plus tangent x. So when I do the derivative of u, the derivative of secant is secant tangent. And the derivative of tangent is secant squared. And I got that dx over here. And then that du, if I factor out my common factor out of here of secant in both of these, I can take a secant out. And that's going to leave, I'm going to move this to the front, secant x plus tangent x dx. Now, if you look at this, this is the whole top part, because there's the secant x plus tangent x dx. So this is going to equal the integral of 1 over u du. Okay, so now I'm going to do the integral of that, which is the natural log of the absolute value of u plus some c. And then I'm going to plug this thing back into the u, so this will be the natural log of the absolute value of secant x plus tangent x plus c. And if you look down here at, it's right here, secant x, that's where this comes from. And we got one more problem to do, and this one's tricky because you got to know some identities. So 1 plus tangent squared is also equal to, from the old days, pre-calc identities. That is secant squared x. That's an identity from the Pythagorean ones. So a square root and a square cancel out, so this is going to be the integral of pi over 4 of secant x dx. And then you have to know the integral of secant x. Well, I think we just found it right there, didn't we? So this is going to be the natural log of the absolute value of secant x plus tangent x. We're going to plug in 0 last and pi over 4 first. So we're going to come on down here, and we're going to get the natural log of the secant of pi over 4 plus the tangent of pi over 4 minus the secant of 0. Oops, I left off natural log, my bad. I gotta put natural log in here. Minus the natural log of the secant of 0 plus the tangent of 0. Should have absolute values there. All right, so I'm going to simplify this thing. So secant of pi over 4. So you got a pi over 4 right here. These are radical 2 over 2 and radical 2 over 2. And you're supposed to know cosine is this x. Well, if you remember, the original cosine is this. So the reciprocal, secant and cosine are reciprocal. So you got to flip this upside down. So this thing right here is going to be radical 2 plus, and this thing right here, the tangent of pi over 4 is that y over x, so this is 1. Now that's positive, so I don't need the absolute value. You can keep them on there if you want. Minus the natural log, the secant is 0. Now the ordered pair of zeros, 1, 0, cosine is 1, the reciprocal of 1 is 1, so this is 1. And the tangent of 0 is 0 over 1, which is 0. So this is the natural log of 1, which this whole thing goes to 0. The natural log of 1 is 0. So my whole answer is the natural log of 1 plus radical 2. That's our answer for that problem. Okay, have a good one, and I will see you next class.